The earliest kind of space station was the single-module station. The Soviet Union's Salyut program, launched beginning in 1971, represented this category. These stations were essentially one large cylindrical module launched into orbit as a single piece. They had no ability to expand, no way to add new sections, and a limited operational lifespan because once their onboard supplies or systems failed, the entire station became unusable. Salyut 1 was the first space station in history, and though it suffered numerous technical issues, it proved that humans could live in orbit for meaningful periods. The United States followed with Skylab in 1973, built from leftover Apollo-era rocket hardware. Skylab was also a single-module station, hosting 3 separate astronaut crews before it was abandoned and eventually fell back to Earth in 1979. Closely related to this early category but often overlooked is the military reconnaissance station. The Soviet Union secretly developed the Almaz program alongside its civilian Salyut missions, disguising military stations under the Salyut name to avoid revealing their true purpose. These stations were equipped with high-resolution cameras and surveillance equipment rather than purely scientific instruments, and some versions even carried a self-defense cannon to protect against potential interception. Crews aboard Almaz stations conducted reconnaissance work alongside limited scientific research, blending espionage with early space habitation. This category shows that not every space station was built purely for science. Some existed for strategic and military advantage during the Cold War. The next evolutionary step was the modular space station. This is where engineers realized that instead of launching one giant piece, they could send up separate modules over time and dock them together, creating a station that could grow, be repaired, and be reconfigured. The Soviet Mir station, which began operations in 1986, was the first true example of this design. Mir started as a core module and had additional modules added over nearly a decade, eventually becoming a multi-part complex with laboratories, docking ports, and living quarters. This modular approach meant Mir could adapt to new scientific missions and international partnerships, including hosting American astronauts through the Shuttle Mir program in the 1990s. Mir remained in orbit for 15 years, far outlasting any single module station before it. This modular concept reached its peak with the International Space Station, or ISS, which is the most complex and largest space station ever built. Construction began in 1998 and involved the United States, Russia, Europe, Japan, and Canada working together. The ISS is made up of dozens of pressurized modules, laboratories, docking nodes, solar arrays, and robotic arms, all assembled piece by piece in orbit over more than a decade. It represents international modular design at its most advanced, allowing continuous human habitation since November 2000, making it the longest continuously inhabited space station in history. Its size is often compared to a football field when accounting for its full solar array wingspan, though the pressurized, livable volume is closer to that of a large house. Beyond government-built stations, we now have commercial space stations, a category that has emerged more recently as private companies enter the space industry. These stations are designed, funded, and often operated by private businesses rather than national space agencies, though agencies may still be customers or partners. Companies have proposed and begun building stations intended for research, manufacturing, and even space tourism. The idea is to create orbital destinations that operate more like commercial real estate than government science labs, with multiple clients renting space or time aboard the station rather than a single government program controlling everything. Within this commercial wave, there's also a distinct category worth separating out: the space tourism station, designed less for research and more for paying visitors seeking an orbital experience. Rather than laboratories packed with scientific instruments, these proposed stations emphasize large viewing windows, comfortable living quarters, and amenities meant to make a stay in orbit feel less like a scientific mission and more like a destination. Some proposals even include artificial gravity sections created through rotation, aiming to make the experience more comfortable for short-term visitors who aren't trained astronauts. This category represents a shift in who space stations are ultimately built for, moving beyond scientists and government astronauts to include private citizens. Another important category is China's Tiangong space station, which falls into a hybrid category worth examining separately, since it represents a newer national approach to station building. Tiangong, meaning Heavenly Palace, is a modular station similar in concept to Mir, built from core and laboratory modules launched and assembled starting in 2021. It reflects how a single nation can now achieve what once required international collaboration, using lessons learned from decades of prior space station development. There's also the concept of the inflatable or expandable space station module, a newer type of technology that changes how stations are built entirely. Traditional modules are rigid metal structures launched at their full size, limited by the diameter of the rocket fairing carrying them. Expandable modules, by contrast, launch in a compact, folded state and then inflate once in orbit, becoming much larger than their launch size would suggest. This technology has been tested on the ISS with modules that expand to provide significantly more interior volume than a rigid module of the same launch mass, hinting at how future stations might be built lighter and roomier than ever before. Looking toward the future, we also have the planned Lunar Orbital Station, a new category designed not to orbit Earth but the Moon. This type of station, sometimes called a gateway station, is intended to serve as a waypoint for missions traveling to and from the lunar surface, rather than a permanent Earth orbit laboratory. It represents a fundamental shift in purpose. Instead of studying Earth or conducting microgravity research, its primary role is logistics and support for deeper space exploration, acting as a stepping stone between Earth and more distant destinations.